Sometimes algebraic expressions contain a common factor with two or more terms. The binomial y plus 2 is a factor of both y to the third and 9. Thus, y plus 2 is a common factor. Factoring out the common factor of y plus 2 results in y plus 2 times y to the third plus 9. Some polynomials with 4 terms have a common binomial factor. In order to identify that factor, we regroup into 2 groups of 2 terms each. Taking this 4-term polynomial, we'll group the first 2 terms and the last 2 terms together. Looking at the first 2, we'll factor this binomial, recognizing we have a greatest common factor of 5 in the numbers and a to the second with the variables, and writing it in that factored form. For the second 2 terms, we have 2a plus 6. Greatest common factor is 2. Here we have it expressed with that greatest common factor. Using the distributive property then, we can express the first binomials as the greatest common factor of those 2, 5a squared, times the remaining factors of each. The last 2 pairs, using distributive property, results in a 2, our common factor, times the remainder of each factor, a plus 3. Looking at this, we now have a common factor of a plus 3 between these 2 terms, and factoring out these common binomials to each, in other words the factor a plus 3, and expressing it as the product of the remainders when that common factor is factored or divided out, which is a 5a squared plus the 2. Here we are asked to factor a 4-term polynomial. In order to identify that factor, we regroup into 2 groups of 2 terms as we did in the last example. Here we have the first 2 terms and the last 2 terms. Factor each binomial. The greatest common factor here is only in the variable x to the power of 2. For the last 2 terms, the greatest common factor is 2, but because it's negative, we're going to use a negative 2 to switch the signs, and we'll see why in just a minute. When we go ahead then and factor this, using the distributive property on the first 2 terms, we have the common factor of x squared times the remaining factors of 7x plus 2. Factoring out the greatest common factor of negative 2 here leaves the remaining factor of 7x from the first term and 2 from the second term. You now see that between these 2 terms we have the common binomial of 7x plus 2. If we had not factored out the negative 2, we would have ended up with a negative 7x and a minus 2, just the opposite of what we had. Now we have the common factor of 7x plus 2 between these 2 groups. Factoring it out for a second factoring step times the remainders, which is x squared and the minus 2 from the second half of our factoring. In this example, to factor, we regroup into 2 groups of 2 terms each, as we have been. It should be noted that if the first grouping arrangement does not factor, one can rearrange the polynomial and try a different grouping. As a first attempt, we will group the binomials as the terms are presented, the first 2 and the last 2. Again, as we've done in the previous examples, we'll factor each binomial. The first two terms have a greatest common factor of 2x squared. The second pair has a common factor of -9 for the same reason that we used -9 the last time. We'll see when we factor each of these why the -9. Factoring the first binomials results in a 2x squared times the quantity x minus 4. Factoring out -9 results in leaving a 9 minus 4, giving us that common binomial between these two expressions that we have. And again, if it hadn't been -9, we would have had a -x and a positive 4 left over, which would not have been the same binomial. Factoring out that common binomial between these two expressions then has a remainder of 2x squared from the first term and -9 from the second term. We can multiply these two binomials together, which will result in, provided we've done it correctly, in the original 4-term polynomial that we started out with.